We're going to graph inequalities. So here we start off, the very first thing you always do is graph, in this case, the absolute value. So we're going to treat this like it was an equals. Alright, so our vertex is -2, -1, and A is -1, which we can treat as slope. Alright, before we graph it though, we need to decide if we're going to have a dotted or solid line here. And the way we determine that, because this is less than or equal to, we're going to have a solid line. Okay, so let's graph this. So we've got -2, -1, and our slope is -1. So right one, down one. Let's continue. You need to continue this all the way out the graph. Now do the opposite. So left one, down one. Alright, so we're going to draw a solid line. Okay, now the next thing we need to do, we need to decide where we're going to shade this. That means in the inside, do we shade the inside or the outside? And the way we can do this is to pick a point. Pick a point not on the graph itself. Alright, so get two schools of thought here. Look at the original problem. It's y is less than or equal to. Less than is down. Alright, so I'm predicting that we're going to shade this thing down. So I could pick a point in my inside because that's underneath my graph. Or, because 0, 0 is an easy point, I can plug that in and see which way I graph. It doesn't matter. I'm going to plug in 0, 0. Alright, so pick 0, 0. Plug it into the original. So I'm going to substitute 0 in for x and 0 in for y. Alright, so I'm going to have 0 is less than -3. That's a false statement. So since that's on the outside and I get a false statement, I need to shade the other region. So I'm going to shade the inside of my absolute value. Alright, let's look at another example. Alright, here again, start off, first of all, we're going to graph it. So graph it as if it was an equal to. So my vertex is going to be 1, -3. And my slope is 3. Alright, so let's graph that. So 1, -3. And my slope is 3. So up 3 over 1. And you got to keep going until you can't go any more on your graph. Okay, now we need to decide, because this is less than, it's going to be a dotted line. So I'm going to dot this, or dash it, whatever you want to call it. Okay, now here again, this is less than, so I'm predicting that I'm going to shade below my graph. Alright, but I've got two parts. I'm going to shade the inside or the outside. Alright, pick a point. Now we can't use 0, 0 this time because 0, 0 is on our graph, so we need to pick another point. So we could pick 1, 0, we could pick -1, 0. It's just a matter of choice. Alright, since I'm predicting that I'm going to shade on the outside, I'm going to check -1, 0. Like I said, it doesn't matter what point you pick as long as it's not on your graph. Alright, plug it in. So I'm putting -1 in for x, 0 in for y. Alright, so what is this? 3, absolute value of -2. That's a +2, so 3 is less than 6 minus 3 is 0 less than 3. That's a true statement. So since my point -1, 0 is on the outside, I'm going to shade the outside of this graph, all the entire outside. Now, the quadratic, you do the exact same thing. So first of all, we need to graph the quadratic. So y is equal to x squared plus 2x. Alright, I'm going to factor this and graph this in intercept form. So my two zeros are x equals 0 and x equals -2. So 0, 0 is a point and -2, 0 is a point. Now to find the vertex, I want to average my zeros. and plug it back in to find my corresponding y. So that's going to be -1. So my vertex is the point -1, -1. All right, so -1, -1. All right, now I can use my parent points, take over. So I've got 0, 1, 2, so I get 0, 1, 4. My A is +1, so I'm going to right 1 up 1, right 2 up 4, 1, 2, 3, 4. And do the same thing to the left. Left 1 up 1 and left 2 up 4. All right, 3, 9 won't fit. Since this is greater than or equal to, I'm going to have a solid line here. Take the graph all the way out off the graph. Okay, so now we need to decide, am I going to shade inside or outside? Here again, I can't use 0, 0. That's one of my points. Since y is greater than 0 and greater than is up, I'm predicting that I'm going to shade this region. So let's pick a point in that region. How about 2, 0? I'm sorry, let's try that again. That's not in that region. How about 0, 2? All right, so let's plug in 2 for y and 0 for x. So it's 2 greater than or equal to 0. That's a true statement, so that my 2 zeros in the inside, so I'm shading where it's true. You always shade where it's true. All right, let's try another one. All right, this one. Here again, I always graph first. So the opposite of x squared plus 2x plus 1. All right, you have a choice. You can put this in vertex form. You can use standard form. Somehow you got to find your vertex. So I'm going to do the opposite of b over 2a. So that's 1. So my y value, plug it back in. So that's going to be 1 squared plus 2 plus 1. So that's going to be 2. So my vertex is 1, 2. Since my a is -1, that means I'm going to go 0, 1, 2, 0, 1, 4, multiply by -1, so 0, -1, -4 is my counting. All right, so let's graph 1, 2, and then from there I'm going to go right 1, down 1, do the reverse, left 1, down 1, right 2, down 4, and left 2, down 4. All right. Will 3, -9 fit? Yeah. So let's do all the points that we can. So my 3, 9, -9. That's where I got my next point. Okay. Since this is greater than, it's going to be dotted or dashed. All right. This is a parabola, so I need to curve this. All right. Where to shade? All right. I'm either going to shade the inside of it or the outside of it. All right, since it's y is greater than, I predict that I'm going to be shading the outside region because it's greater than. So I'm going to pick a point in my outside region. I'm going to pick 0, 2. All right, so plug in 2. I'm going to get 0 plus 1 is 2 greater than 1. It is 2 zeros in this outside region, so I'm shading the outside. Make sure you shade all the outside. All right, so that's graphing an inequality. Pause this video if you need more time. All right, next we're going to graph a system of inequalities. So 2 inequalities. So we got to graph both of these on the same graph. All right, so same process. I'm going to graph it as if it was equal. So I got 2x squared minus 4. So this means my vertex is 0, -4, and my a is 2. All right, so I got 0, 1, 2, 0, 1, 4. I'm multiplying by 2. So I've got 0, 2, 8. All right, and because it's greater than or equal to, it's going to be a solid line. So let's do that. So I've got 0, -4. All right, I'm going to go right 1 up 2. So do the opposite, left 1 up 2. Right 2 up 8. And do the opposite. All right, and it's solid. So there's my first graph. Alright, now, if I were to shade this one, since it's greater than, I don't want to do any shading yet because I want to see where they overlap, so it gets too messy otherwise. Since this is greater than, I'm going to be, I would shade on the inside. So I'm going to just draw these little arrows in here to show where I would shade. And you'll see where I'm going with this in a moment. Okay, let's change colors and graph that second one. So we're going to graph y is equal to the opposite of x squared plus 3. So this one has a vertex of 0, 3. Alright, my a is negative 1, so my parent point's here, 0, 1, 2, 0, 1, 4. I'm multiplying by negative 1, so 0, negative 1, negative 4. Alright, so 0, 3. Alright, now since this one is less than, it's going to be dashed or dotted. Alright, I'm going to go right 1, down 1, right 2, down 4. Try that again, 1, 2, 3, 4. And left 1, down 1, and left 2, down 4. Alright, so this one is dashed. And we could do the 3, 3, 9, which becomes negative 9. Let's do that too. 1, 2, 3. Okay, so let's do it all the way out our graph. Okay, so now this is less than. So that would be shaded down. What you're looking for is the region that has this both sets of arrows in it. So see here in the middle, I've got my up arrows and my down arrows are meeting here in between. So that is the solution to this graph. Now what would happen if you picked a point? Alright, it would have to make both of these true. So check, a good way to check this is like check a point. Let's pick 0, 0, since it's in this region. Check it on both graphs. So the first graph we're going to get, what is that, 0 minus 4. 0 is greater than negative 4. That's true. Let's check it on the second graph. So you're going to get 0 is less than 3. That's also true. In order for it to be correct, but it has to meet, the same point has to be true in both graphs. Okay, let's solve. Haven't seen this joke yet. What sound does a turkey's phone make? Wing, wing. Get it? Wing, wing, ring, ring. Okay, let's solve. Here's a different type of problem. Notice there's no y value here. So the previous questions had a y, so we were doing it on the coordinate plane. Here we're going to solve a quadratic algebraically. All right, these are the steps you're going to follow every single time. So you need to memorize these steps. First thing we're going to do, we're going to rewrite this greater than or equal to using an equals. All right, write the corresponding equations. So it's going to be x squared plus x equals 12. I'm finding my critical values here. All right, write this in standard form because I'm solving a quadratic. All right, I want to factor it. So it multiplies to give you negative 12, but has a difference of 1. So 4 and negative 3. So when I factor this, I'm going to get x plus 4, x minus 3 equals to 0. Use the zero product property. So x equals negative 4 and x equals positive 3. These are called my critical values. So the numbers negative 4 and 3 are my critical values. So we're going to end up here with an and or statement, just like we did with our absolute values. We solved absolute value inequalities. Okay, so that's the first 4 steps. All right, what we're going to do now is we're going to plot those numbers again, make sure. Negative 4 and 3. We're going to plot negative 4 and 3 on a number line. And because this was greater than or equal to, we're going to have closed dots because it was greater than or equal to. Okay, so let's pick a spot for 0. So negative 4. We got a closed dot. Positive 3. We got a closed dot. All right, now what we have to do is test an x value in each interval to see if it satisfies the inequality. We got to decide where we're going to shade. Is this going to be an or, which will go out, or an and, which will go in. We have to decide which way we're going. The way we do this is to test values. Now, we don't want to use our critical values. So now I'm testing something in this region. So let's put in -5. All right, let's go back to the original question. So we're going to go x. So I've got x squared plus x is greater than or equal to 12. We're plugging it into that. So what is that? 25 minus 5 greater than or equal to 12. Is 20 greater than or equal to 12? That's true. So that means we're going to graph this part of our graph. All right, test 0. That's an easy one to test. You don't have to be 0. You can do -1, you can do +1, but 0 is an easy one. Plug it into the original equation. Is 0 greater than or equal to 12? No, that's false, so we're not going to graph it. All right, let's test a point in our final region over here. Let's do 4. All right, what do we got? We got 16 plus 4 greater than or equal to 12. So 20 is greater than or equal to 12. That's true, so we're going to graph that. All right, what kind of graph is this? They're pointing opposite directions, so this would be an OR. So our final answer is x is less than -4 or x is greater than 3. So you can pick any number that's less than -4, less than or equal to -4 or greater than or equal to 3, and it would make that inequality true. So it kind of acts like an absolute value graph. So remember when we did absolute value, greater was an OR question. But here's a way to double check it. All right, let's do one more example. All right, here. So the first thing we want to do is solve this quadratic. So set it equal to 0. All right. I notice that everything is divisible by 3, so I'm going to do that to make my number smaller. All right. So I want to factor. My next step is to factor. So what multiplies to give me -4, but has a difference of -3? So -4 and 1. So x minus 4, x plus 1 equals to 0. So my two critical values are 4 or -1. And since this is less than, I'm going to have open circles. All right, so let's graph those. So I've got -1, it has an open circle. I have 4, and it has an open circle. All right, let's make a prediction. It's less than. Remember from absolute value, less than was an and. So I believe I'm going to be going in between these two numbers for an and. Let's test our region. All right, so we got 3 regions. I'm going to use x equals -2. Plug it into the original. What do I end up with? That's 12 plus 18 minus 12 is less than 0. Is 18 less than 0? No. So I'm not going to shade it. All right, let's do it in the middle region. I'm going to use 0. It's easy to use. So 0 minus 0 plus or minus 12 is less than 0. Is -12 less than 0? That's true. So I'm going to shade in that region. Or I'm going to graph in that region. All right, let's just make sure we didn't do anything silly. Let's test the number up here too. So let's use 5. All right, what do we got? 25 times 3 is 75 minus 45 minus 12 less than 0. Well, that's not going to be less than 0. What is that? 75 minus 67 less than 0. What is that? 8? 18? No, 8. 8 is not less than 0, so I don't shade or don't graph that region. Okay, so now you haven't done your final answer. You got to write up your final answer. Your final answer is an inequality. So my final answer, because it's in between the two graphs, x is going to be greater than -1 and less than 4. So it checked out. Because that was a less than, it's an and. Okay, hope this helps. Watch it. Come with questions. Fill out your notes. And I'll answer questions you have in class next time.